the review package for our transformations and conics skills. All right, so let's go through these questions one at a time here. So question 1 says, using precise and accurate language, describe the transformations involved in going from y equals f of x to y equals 10f of negative 5x minus 15 plus pi. All right, so in order to describe these transformations, I need to put this in a form of y equals a f of b, x minus c, plus d. So the general function here, f, has an a value, which is a transformation stretching or dilating by a factor of a, and it can also flip it over the x-axis. B flips it across the y, or compresses or stretches by an inverse or reciprocal. So remember that. C, this value c, shifts it left to right, or translates it left to right, and d translates up or down. And d translates up and down. Okay, so we could go through this by deciding what our letters are. But before we get started, we have to remember that this function needs to be put into this form, and I notice there's no second set of brackets here, meaning this negative 5 has not been factored out of both of these terms. So I'm going to rewrite it with a negative 5 factored out. And this has to be equivalent to this form. Okay. And so that looks like I've got negative 5 and multiply it by x, and negative 5 times blank gives negative 15. Negative 5 times positive 3 gives negative 15. Okay, so I think I'm going to go ahead and highlight this all up. So it looks like I've got an a value here of 10. Okay, that's definitely smudging everything. So maybe highlighting in that way isn't the best. I could figure out something else. All right, so this tells me that, maybe I'll try find the highlighter first. A, well, it still bleeds, not great, equals 10. So this says that we have a vertical stretch or dilation by a factor of 10. Okay, so for pink, I'm going to use pink for B. This tells me that my B value here is negative 5. So that says B equals negative 5. All right, and that tells us that we have a horizontal, and we need to remember that this B value is always actually acting as its own reciprocal, so actually it's going to not expand but compress, which is also a dilation, by a factor of 1 over 5. 1 over, 5. However, it was also negative, so that means in addition there's another transformation that comes out of our B value here, which is that we have a reflection over the, this is the x, oh, pardon me, the y-axis. Okay, let's see what other colors I have here. Got a green highlighter, all right, so let's try that. So then we'll look at this guy here. This positive 3. That relates to our C value here. So that tells me that C is equal to, okay, so what number must have been subtracted from x to get positive 3? In other words, if I could write this as x minus blank, Well, that value would have to be -3. So that means C is equal to -3. And so what this means is that we have a, wait, which direction? Oh yeah, horizontal translation. And it's also known as a shift. 3 units left. Okay. And where did my orange highlighter go? I just had it. How bizarre. All right. Maybe I'll use this blue pen. There we go. All right, and lastly, our D value here. And so that corresponds to our value for pi. So what that tells me is that my D value equals pi. And so that tells me we have a vertical translation, pi units up. And that's it. All right, so let's move on. Question 2. Okay. So we have some point, 3, -48, and it's on the graph of our function f. So what that means is that the point P3, oh, it's not actually going to be there, that's stupid. 3, -48 lives here, and the rest of the graph does who knows what. It doesn't really matter to us. And that's f of x. And so that graph is going to get transformed a whole bunch of ways. And when that all happens, this point, just like all the other points, are all going to get shifted around left and right, up and down. So as long as we can figure out the transformations one at a time that are going to work this point around, we should be able to figure out exactly where that point lies when we're done. All right. So what do we have here? We've got 5 transformations, and I know that we have this memory device, right? It was don't reuse toilet paper, right? Which means we need to do our dilations before we do our reflections, which means, and then we have to do our translations. So I'm going to look for my dilations first. That's A and B. Actually, so are the reflections. The reflections are also A and B. And translations are our, oh shoot, you know what? I screwed up. I forgot we were using H and K, these letters. I like to use C and D. H and K. Okay, so it looks like my homework on YouTube is to try and find a way to edit the video so that that's obvious. Alright, now. So I'm going to try to list my dilations first. Okay, so the first dilation I see is that I have a 2/3 here. That means I have a vertical stretch or compression by 2/3. And then I have a horizontal expansion by, remember I need to take the reciprocal of a third, so that's going to be by 3. And then I have that's all my dilations. I have a vertical one and a horizontal one. Check. Then I go for my reflections. I have a reflection of, reflection over the x-axis. Okay, what else? I have this shift now that's my reflections done, I can move on to my translations. So these guys are my translations. I have a horizontal shift to the left 8, and I have a vertical shift down 9. And I'm going to call these transformations transformation 1, 2, 3, 4, and 5. And what's really important here is that I recognize what these guys do to a point. So my point I, that's going to take, so maybe I'll circle them to differentiate them. So 1, well that takes my point x, y, and shifts it to the value x, and then instead of y, it's going to be compressed by 2/3, so I'm going to get 2/3 of y. So that's going to be my first transformation. All right. So that's going to happen to this point just like it's going to happen to all my points. So I start with the point 3, -48. Then I undergo transformation 1, which means I'm going to, it looks like I keep my x the same, but my y value is going to become 2/3 of the y value it currently is. Now, 2/3 of -48 is -32. I think I'll just double check that. -48 times 2/3, -32. Okay. So my y value is now -32. Okay. So that means instead of being at 3, -48, it's going to have moved up to -3, -32. We don't actually need to draw a sketch of this all the time, but I may draw a few steps just to clarify what we're doing here. And then I can move on. What's my next transformation? So transformation 2 is going to take any point x, y, and shift it. Pardon me, stretch it. So my x value is going to become 3 times bigger than it normally was. And so that means instead of 3 here, I'm going to have the point 9 at -32. So this guy is going to now shift outward. If that was 3, and it's at 9/32. Okay. And then we've got another transformation here. Transformation 3, which says a reflection over the x-axis. So that means I take my point x, y, and when I flip it over the x-axis, my y values become negative y values. And so that means if I'm going to multiply, pardon me, let me finish my thought there. I was distracted. It's going to become the value of reflecting over the x. So I'm going to multiply my y values by -1 y. And so that means that my x doesn't change. I have the point at 9, and instead of -32, it's going to go to +32. Okay, getting there. Step 4, well, what does 4 do? 4 shifts left 8. So that means I take, for any point x, y, and replace it with the value x take away 8, y. So while flipping this across the x-axis, put my new point up here, now it's going to shift to the left 8. So I'm going to rewrite my point here. Instead of, it looks like my y is going to stay the same. It'll still be at 32. But my x value is going to be 8 less. 8 less than 9 is 1. So actually that wasn't to scale. I guess it needs to go over here. Not that this is a 2-scale diagram anyhow. All right, and then lastly, I have this 5th point, which is a vertical shift 9 units down, which means I'm going to take my value x, y, any coordinate, It's going to keep the x the same, and it's going to take away 9 from y. So my last point, this is our final point, is at the point, so I'll keep x the same, and I'm going to take 9 away from 32, so that's 23. And that's it. So, point P is translated, or transformed, rather. Translated just means shifted. Transformed is a general term we use for any of these transformations to the point 123. All right. So let's move on. All right. So the graph of f of x is shown. Okay. And we want to draw a graph of negative 3f of half x minus 6. So I've got a negative 3 here. This half. And this positive 6. All right, those are going to translate to, I'm going to use highlighters to specify which each of these steps. And my yellow value here means my a value is negative 3, meaning I have a vertical stretch by 3. Also, it's negative, so that means we have a reflection over the x-axis. And then we have our b value, which is 1/2. And so that means we have a horizontal expansion by a factor of 1/2. So 1/2 is 2. And then lastly, what do we have? Our our h value is negative 6. And so that tells us that we have a shift 6 units left. Okay. So we're going to start with step 1. We have a vertical stretch times 3. So that means all of my, I'm going to choose my 4 points here. And so these are the points negative 2, negative 2. This is going to be, I hope I can do this without making this too messy. I'm going to just write this one then. That's point 2, 1. And then I'm actually not convinced I can write the points for all of those on this graph without making too big a mess. So what I'm going to do is try to transfer some of that information down here. All right. Now, before I do that, I'm going to get back to what I was doing before, which is defining what each of these transformations does. So the point xy becomes the point x3y. Reflection over the x-axis means the point xy becomes the point x negative y. Horizontal expansion by 2 takes point xy and makes my x values, my horizontal values, 2 times bigger. Becomes 2x y. And lastly, the point horizontal shift left 6 takes any point x, y and shifts it 6 units to the left, x minus 6 y. Okay. So what I'm going to do is I'm going to list all 4 of these points. I'm going to transform them one at a time. And each time I do that, I'm going to demonstrate what's happening in terms of yellow highlighters here for this transformation. All right, so my 4 points are the points negative 2, negative 2. Then I have the point negative 2, negative 1, negative 2. Oops. I have the point 0, negative 3. And I have the point 2, 1. And the hope is that by sketching all these out one at a time, I should be able to get this new shape approaching. All right. So I think we'll put numbers next to each of these steps. So that's going to be, got to do my, so we have this rule, don't reuse toilet paper or dilations, then reflections, then translations. So that means I need to go through here, and I will say that's going to be step 1, that's going to be step 2, this will be step 3, this will be step 4, and so one step at a time. So my first step is I'm going to stretch vertically by a factor of 3. So all these values are going to become y values 3 times bigger. That's going to become the point negative 2x doesn't change, but my y value does. My y value becomes 3 times bigger, so instead of negative 2, it's negative 6. And that I'm going to indicate with a yellow highlighter. That's the same thing with this guy. He starts in negative 1, 2, so now he's become negative 1, negative 6. This guy becomes 0, negative 9, and 2, 3. Each one of these is going to be yellow colored when I graph these new points. So negative 2, negative 6. It's going to go down here. Negative 1, negative 6 is down here. 0, negative 9 is 0 down here. And then 2, 3 stretched up here. So that looks like this. Okay, now I know that's not going to scan well, so in addition, I'm going to draw some dots here. And I'm going to use a lighter pen to draw a few points, not too many that they're going to bleed significantly, hopefully. So that if I want to scan this, or you just want to look at this as a PDF, you can see what our first step was. All right. That's our first step. Our next step is a horizontal translation by factor of 2. So each of these points are going to now be multiplied by 2. So that means, or the x value is going to get multiplied by 2, I should say. So my x value is going to become negative 4, negative 6. Negative 2 times 2 is negative 4. Negative 1 times 2 is negative 2. 0 times 2 is 0. 2 times 2 is 4. All right, so I will color those pink because, well, we did say that we were going to use pink for our horizontal expansion here. Okay. So I'm going to sketch those points using a pink highlighter. So I've got the point now negative 4, negative 6, which is here. Negative 2, negative 6, which is here. 0, negative 9, which is overlapping with this guy. And the point 4, 3, which is 4, 3, is right here. So then I get this new sketch. Connect these dots. Comes down like that, and then it's going to come out a little bit wider because it all got stretched out just a little bit. And like I say, I'll, out of concerns for scanning, going to just do little dotted lines along that highlighter so that it'll show up on the scanner. All right. So next, we need a reflection. So we're going to take all of our values, x, y, and then we're going to take these y values and make them negative. If they were negative, we're going to make them positive. All right. So this value is going to go to the point negative 4, positive 6. -2, positive 6, 0, positive 9, and 4, -3. Now, you don't have to do all of these steps all at once like this, or rather, all written out like this. That's not necessarily required. I'm writing out some extra steps because it's easy to get confused doing this, and so if you feel like you need a something to refer to or like a procedure, you can always just go to some steps like this. All right, so now my new point is at -4, positive 6, so it's reflecting up over the y-axis to come up here. Oh, I should use a highlighter. And right, I want an orange highlighter for this one. Now I just had one somewhere. I'm just gonna see if standing up is gonna help me find it. All right, well, I think what I'll do for this one then is I'll use yellow again, because it does refer to a transformation bit stems from this A. So I'm going to use yellow for a second step here. So this point, -4, 6 is going to be up here. And instead of -2, -6 is going to be -2, positive 6, so up here. And the point 0, -9 down here flips upward to 0, positive 9, 7, a little bit off the graph, 8, 9, so up here. And then the point 4, 3 is going to become 4, -3, so down here. Okay. Now it doesn't show up super well on this dot cam, so I'll start by connecting these dots. This is probably going to be a straight line, reflecting that straight line up. Little curve up here to go upward. And down. Like that. Gonna